Welcome back. Today we're cracking open Chapter 7, Thinking and Intelligence. Yes, that means it's time to explore how we form thoughts, solve problems, and why IQ tests don't measure your ability to find your missing left sock. Cognition is the stuff going on between your ears where you're not just reacting to a cat video. It includes thinking, planning, problem solving, perception, language use, everything that makes your brain the overpriced supercomputer it is. Sensations and information are received by our brains, filtered through emotions and memories, and processed and become thoughts. We categorize stuff to keep from losing our minds. Concepts are mental groupings, like chair or professor who grades too hard. Prototypes are the best example of that group. A golden retriever might be your dog prototype. A hairless chihuahua, maybe not. This slide is where we take abstract psychological ideas and turn them into mental IKEA instructions. No Allen wrench required. Imagine your brain is running a film filing cabinet. Yes, like the old metal kind that squeaks when you open it. Natural concepts are the I learned this by bumping into it repeatedly. You met a dog. It barked. Cool. You met another dog. It barked less. Still a dog. You met a chihuahua. You questioned everything, but it's still a dog. These files are smudged, misfiled, and probably sticky, but they work. Natural concepts are messy and flexible because your brain built them through lived experience. Think Wikipedia edited by toddlers. Now flip to the artificial concept store. It's alphabetized, color-coded, it smells like highlighters and existential dread. A triangle has 3 sides. That's non-negotiable. A bachelor is an unmarried adult male. Unless you're the TV show, then it's chaos. A prime number is only divisible by 1 and itself, unlike your weekend plans. These concepts are clean, rule-bound, and come with instructions. You don't feel your way into artificial concepts. You memorize them and hope nobody asks you about Venn diagrams at a party. Schemata, because your brain can't be bothered to learn everything from scratch every single time. You see a restaurant menu and don't panic. Think your schemata. These are mental frameworks like default blueprints for how we expect the world to work. Schema for restaurant equals wait to be seated, order food, and don't scream. Schemata for lecture. Sit quietly, take notes, try not to zone out until at least slide 6. Schemata are how your brain fills in the blanks without consulting Google. They help you predict, organize, and interpret, all without short-circuiting over whether soup is a beverage. They're formed through experience, reinforced over time, and snakily shape how you see everything, kind of like an invisible lens you didn't ask for but can't take off. They help us understand new information quickly. They also cause stereotypes, biases, and assumptions on the flip side. So yes, your brain is efficient, but also kind of judgy. There are types of schemata, because we're fancy: role schema, event schema, and self schema. Event schema, also known as scripts, for example, how you behave at a wedding or avoid exes at one. Role schema, how people should act. Self schema, who you think you are. These aren't just ideas, they're shortcuts your brain uses to keep you from combusting during small talk. Whether you're navigating brunch, blind dates, or business meetings, schemata are quietly steering the ship. Sometimes they're helpful, sometimes they're outdated, but always, always they're there whispering. We've seen this before. Language, the human brain's most advanced tool for forming society, writing poetry, and starting arguments on the internet. What is language? It's more than words. It's a structured system for communicating thoughts, feelings, and existential dread. It's made up of rules and symbols that let us say anything from past assault to I think, therefore I am. In short, it's how your brain translates thoughts into sound waves your roommate ignores. Let's dissect the thing like a linguistic frog in psychology class. Phonemes are the small units of sound, like B, A, and T in bat. Morphemes, the smallest units of meaning. Example, un plus happy equals unhappy. Syntax are rules for sentence structure. Yoda breaks them for dramatic effect. Put it all together and you get language, a system that somehow lets you ask your barista for half calf oat milk, no foam latte, and have them understand you without blinking. Two brain regions are the rock stars of speech, Broca's area, which helps you speak, and Wernicke's area, which helps you understand. Damage Broca's area and you'll know what you want to say, but you won't be able to say it. Damage Wernicke's and you'll speak fluently, just not intelligibly. Think word salad, but less delicious. Babies aren't just cute noise machines. They coo, babble, and eventually become fully articulate, snack-demanding tyrants. Skinner said language is learned through reinforcement. Chomsky said we're born with a language acquisition device, which is basically a built-in grammar tutor. Either way, kids figure out language fast, often faster than adults can agree on how to pronounce GIF or GIF. Ever heard of the linguistic relativity hypothesis? It says that the language you speak influences how you think. Like how some languages have multiple words for snow, and English speakers have slush. In other words, if your language doesn't have a word for it, your brain might not even notice it. That's not just fascinating, it's mildly terrifying. So the next time you utter something profound, poetic, or painfully awkward, thank your brain and language for the privilege. It's the tool that makes us human, funny, and occasionally unbearable. Problem solving. We'll tackle the mystery, magic, and mild madness of problem solving and its numerous built-in traps. At its core, problem solving is this. You have a goal. You are here. There's a gap. How do you bridge it? Trial and error. Try some stuff until something works. Classic. Also known as my method for assembling IKEA furniture. Algorithms, step-by-step procedures that guarantee a solution, like a recipe, if you follow it and don't substitute logic with vibes. Heuristics are mental shortcuts, faster, easier, occasionally wrong. Looking at you, just wing it strategy. These methods range from efficient to close enough, and they work until they don't. Here's some different puzzles and the answers to the puzzles. So try those out. And now we're going to move on to pitfalls to problem solving. Trying the same solution over and over because it worked once, like hitting the elevator button repeatedly and expecting results. This worked on that one math problem in 1998. Why isn't it working now? Functional fixedness. You can't see new uses for familiar objects. You need a paperweight, but you can't see that mug on your desk as anything but a caffeine delivery system. It's not a hammer, it's a stapler with a dream. Biases. Confirmation bias. You only look for evidence that supports what you already believe, like Googling why I'm right about everything. Spoiler, your brain is not looking for truth, it's looking for a high five. Overconfidence. You're sure you can do it until you're not. This is how people end up deep frying turkeys indoors. Confidence high results disaster. Hindsight bias. After the fact, you totally knew the outcome. Except, no, you didn't. You're just narrating your life like a smugged time traveler. How to solve better. Take a break. Your brain does background processing like a shady laptop. Change your perspective. Ask, what would someone else do? Preferably not your cat. Be open to being wrong. It's how science works, and also why we're not still treating headaches with leeches. Problem solving is a core human skill, right up there with blinking awkwardly and forgetting passwords. But it's not just about solutions. It's about navigating around the blind spots your brain lovingly builds for you. Biases are those sneaky mental shortcuts that make you think you're always right, even when you're confidently wrong in HD. Classifying intelligence. That's right. Turns out there's more than one way to be a genius. So put down your IQ score and pick up your nuance. Charles Spearman, he said intelligence boils down to one thing. G, short for general intelligence. If you're good at math, reading, puzzles, and probably playing chess with your cat, that's G in action. Basically, Spearman thought intelligence is like hot sauce. If you got it, it shows up in everything you do. I'm going to move to Gardner. Howard Gardner came in and said, hey, hold my theory. He'd introduced 8, yes, 8 types of intelligence, like he was handing out Hogwarts houses. Linguistic is wordsmiths unite. Logical mathematical is the calculator kids. Musical are human iPods. Bodily kinesthetic is Olympic gymnast and your yoga teacher. Spatial are people who can actually fold a map. Interpersonal, emotional Jedi. Intrapersonal are your deep thinkers. And journalers. Naturalistic are the ones who know 47 types of moss. Gardner's theory says everyone's smart, just in different ways. Your talent for parallel parking, probably spatial intelligence. Unless you're terrible at it, then, well, not so much. Now we'll talk about Sternberg and his triarchic theory of intelligence. He trimmed it down to 3 types of intelligence because 8 was a bit much for Monday mornings. Analytical, traditional IQ test stuff. Creative, problem solving when the rules aren't clear. Practical, street smarts, or as Grandma calls it, not being a dummy in real life. Sternberg's the guy who says being book smart isn't enough. You've also got to be clever and not microwave boil. Cattell divided it into crystallized and fluid intelligence. Crystallized is the acquired, so what you learn over time, and fluid is the ability to see complex relationships and solve problems. So the actually being able to know how to do something. So the difference would be crystallized would be knowing facts, and fluid would be knowing how to do something. Now we'll go back back down here and move to emotional intelligence, where Daniel Goleman said, okay, cool, but what about emotions? Emotional intelligence is being aware of your own feelings, managing them, and not turning into a stress tornado at every group project. Emotional intelligence is the reason some people lead teams and others yell at printers. It's not about being nice, it's about being intelligently human. So, what do we learn? Intelligence isn't just one test score, it's a buffet of abilities. You might not ace algebra, but if you can diffuse an argument and remember your worker's gluten allergy, you're probably doing great. Creativity, the glorious, chaotic process that makes humans invent art, solve problems, and put cheese on things that should not have cheese. Creativity is ability to produce original, valuable, and sometimes totally bizarre ideas. It's divergent thinking, problem solving, and the unshakable belief that maybe glitter does belong in science presentations. It's not just for artists, engineers, scientists, TikTok chefs. It's all creative. It just shows up in different fonts. Divergent thinking generate many possible solutions, like brainstorming new uses for a spoon. Could be a weapon, a mirror, a cat toy. Convergent thinking is you find one correct answer, like solving a riddle or choosing which of your bad ideas is the least catastrophic. Creativity lives in the space where logic takes a coffee break and your imagination starts rearranging the furniture. Measuring intelligence becomes nothing says nuanced understanding of human cognition, like boiling it all down to a number between 70 and 160. Let's start with the OG of mental measurement, IQ test. Back in the early 1900s, French psychologist Alfred Binet developed the first one to figure out which kids need extra help in school, not to create a worldwide academic arms race. Binet wanted to help students. We turned it into a status symbol. Humans 1, humility 0. How IQ is calculated. Originally, IQ equaled mental age over chronicle age multiplied by 100. So if a 10-year-old thinks like a 12-year-old, boom, IQ's 120. If a 40-year-old thinks like a 10-year-old, we have a separate conversation. Modern IQ scores use standard deviation to create a bell curve. Average equals 100, 68% fall between 85 and 115, genius is above 130, and below 70, potential diagnosis for intellectual disability. Remember, these are estimates, not Hogwarts houses placements. Don't get too cocky. Major intelligence tests include Stanford Binet, the Wechsler Adult Intelligence Scale, and the Wechsler Intelligence Scale for Children. The Standard Binet is the fancy remake of Binet's original. The WAIS is for grown-ups, and the WISC is for mini brainiacs. These tests look at verbal comprehension, working memory, perceptual reasoning, and processing speed. If you've ever finished a puzzle while spelling caterpillar backwards, you've done something like this. There is cultural bias for these tests. Turns out not everyone grew up playing Sudoku and spelling rendezvous. Also too narrow. IQ doesn't measure creativity, emotional intelligence, or how good you are at surviving a family dinner. Basically, IQ tests are like using a ruler to measure flavor. Technically useful, but a bit off the mark. So can we really measure intelligence? Kind of. Should we base our self-worth on it? Absolutely not. Because intelligence isn't a number. It's a whole messy, glorious, ever-evolving brain. technically called the normal distribution. The bell curve is that pretty mountain-shaped graph you see in psychology, education, and your nightmares before standardized testing. It shows how traits, abilities, and scores tend to spread out in a population. Most people, smack dab in the middle. Outliers, you dazzling weirdos, are on the skinny ends. Let's throw IQ on it. Here's how it breaks down. The mean or average is 100. Standard deviation is 15. 68% of people fall between 85 and 115. Congrats, you're deliciously average. 95% between 70 and 30, also known as you're either smart or smart adjacent. 2.5% on each tail, genius or struggling. Translation, the bell curve is just the universe's way of telling you you're probably fine. Calm down. Why should you care? It helps psychologists spot outliers like gifted kids or those needing extra support. It's the basis for standardized testing. Love it or rage against it. Explains why the world is mostly average with a few dazzling exceptions, and Florida man headlines. A quick warning before your brain goes full stat wizard. There's an illustration of it. The bell curve does not mean that ability is fixed. It's not a judgment, it's a description. And it definitely doesn't account for environment, motivation, or whether you had breakfast. Don't use it to decide who's better. Use it to understand variation and maybe how to curve that exam you bombed. The bell curve, comforting, ruthless, and sneakily powerful, just like your grandmother. Remember, it's a tool, not a label, and you're more than your spot on a graph. Let's start with team nature, also known as you were born this way. It includes your genes, which provide the blueprint. Studies show identical twins raised apart still have very similar IQs. If your parents are smart, there's a statistically decent chance you inherit some of those brainy bits. Basically, if your IQ is 140, your DNA gets the credit. If it's 85, it's suddenly how you were raised. Funny how that works. Now entering the ring, team nurture. Early childhood education, critical. Nutrition, brain fuel. Stimulating environments, good schools, bedtime stories, all boosts for cognitive development. Oh, and trauma, poverty, and stress can absolutely hold intelligence back. So if you're raised in a chaotic home with no books and only Wheel of Fortune reruns for stimulation, yeah, nurture had a say. The plot twist. Spoiler, your intelligence is based on both. Genes may set the potential range, say IQ 90 to 120. Environment decides where in that range you will land. Did you get math camp or Minecraft till 3 a.m.? Think of it like a recipe. Nature gives you the ingredients. Nurture decides if you make a souffle or burn toast. Learning disabilities are neurological disorders that affect how people receive, process, store, and respond to information. Not laziness, not low intelligence, not trying hard enough. These are real brain-based differences. Imagine running a race with your shoelaces tied together, but you're still expected to win. That's what learning with a disability often feels like. Dysgraphia impacts handwriting, spelling, and organizing ideas in writing. Words don't come out right or stay on the lines. It may look like a messy essay, but it's a storm of effort behind the scenes. Dyslexia is difficulty with reading, spelling, and decoding. Letters dance, words blur, phonemes refuse to behave. It affects comprehension and fluency, not intellect. Learning disabilities are not a sign of low intelligence, not cured by trying harder, not something people just grow out of. If someone has a learning disability, yelling instructions louder won't help. But assistive tech, patience, and a teacher who gets it, game changing. Causes, it's complicated. Genetics, yes. Brain development, you bet. Environment, trauma, or even birth complications, potentially. But here's the key: it's not anyone's fault. Some of the most brilliant innovators struggled in school. That's not a coincidence. It's proof that traditional learning doesn't fit all brains. Learning disabilities don't mean someone can't learn. It means we need to teach differently. It's not about lowering expectations, it's about unlocking potential. See you next time.